Yes, a very good day to you and welcome to yet another exciting edition of the program Agric Today. Agric Today is a program where we bring you the latest when it comes to the world of agric. When I said latest, I mean by crop production, I mean the mechanization, and talk anything new when it comes to the world of agric. Today we'll be looking at the processes in ensuring that we have a good bountiful harvest when it comes to the root crops, and today our focus is going to be on cassava. Yes, I will take a very long road show down to Umudike, where we'll be visiting the National Root Crop Institute, where root and crops are being enhanced for better food for all, and then ensure that the nutrients are complete, and then Nigerians have enough to feed. And then receiving us in Umudike is the coordinator in the person of Mrs. Hihioma Okwoma. She said the mandate of the center is to ensure that all roots and crops are being improved with biotechnology. Like I said in one of the editions where we have the OFAB country director in the person of Mrs. Rose Gidado, she talked about the importance of having these biotechnological improved seeds. On that episode we talked about cowpea, which is our regular beans, but today we'll be looking at cassava, how but we can use biotechnology to improve our cassava. On this episode, yes, we went to Umudike and then we brought to you step by step a process of ensuring that this plant, this root crop called cassava, is being done in the most healthiest. In fact, I was very amazed to see how this cassava are being done, and it's the same thing. It stands the test of time. Let's take a quick break. Let's just take you around how the facility looks in Umudike, and then when we return, we'll bring you the coordinators taking us around. Stay tuned. It's still the program Agric Today, and like I told you, this trip is taking us down to Umudike, And yes, the coordinator of the center took us around, the facility. And our first step is at the ACE 101 Molecular Biology and Diagnostic. Here she showed us how, the formations of this cassava is being done, and how the planting processes go before, it goes to the main farm outside. So let's follow her and see what she has to say.
This facility is for molecular breeding and molecular diagnostics. So what do I mean? Previously we could cross plants together to get offspring, varieties that we test in the field. But nowadays we're using biotechnology methods whereby we're able to fast track the breeding process. So in this laboratory, what we do is that we use, you see the machines that you see here, we use marker-assisted breeding, we use genomic selection, and we use genetic engineering to improve our root and tuber crops. And in other words, being able to produce this variety faster than you would have with conventional breeding. And for molecular diagnostics, here we produce diagnostic kits. For example, the machines you see here is called PCR machines, and we use them to be able to dictate diseases, viruses, bacteria, fungi that may affect the farmer's field. So we collect samples from the field, we bring them to the laboratory, and we test them. So we tell the farmers, your farm is infected or your farm is not infected. These are the recent versions of the PCR machines. And then there's another one that we call, it's a different type of PCR, real-time PCR. When you use this kind of machine and you run your reaction, you will have to run it on a gel. I will show you the gel to see what the result is. This is gel electrophoresis. So whereby the samples you get from there, you put them on the gel. If you can just look at this, what you're seeing on the screen. So this is showing you your band. In PCR, what you're looking at is bands. This tells you, for example, if my material is infected by a virus, I cannot see it with my eyes. But when I use molecular tools, I can amplify that virus, and then I'll come on the screen and it tells me whether it is present or absent. So that is the beauty of this technology. So this is our -80. Remember I told you we can store biological materials, our materials. So this requires constant light in order to keep your material frozen. So here we keep root samples, we keep leaf samples, we also keep our bacteria samples that we're using to work. So you store them here, and whenever you bring them out, they are as fresh as when you put them in. This is our bacteria room, and what we do here, because we work with bacteria, oftentimes the agrobacterium, and we also work with the E. coli for transformation. So you see, these are incubators. We have about 1, 2, 3, 4 of them, and why we have them as such is that agrobacterium requires a different temperature and E. coli requires a different temperature. So oftentimes we're working with the two bacteria and we need to put them at different temperature. And oftentimes also, because we need to do inoculum build-up, we need to build up our organism to a particular capacity. So we need to have it shake. So this is a shaking incubator as well as that.
Upon arrival at one of the labs, Dr. Hioma showed us around the media room, and then she handed us over to one of the lab technologists who now explained what some of the equipment in his own session of the lab has to do. Let's hear from him.
This is our media room, or we call it media kitchen. So this is where we make media. Can I have a sample of media, please? Sample of media. So this is where we make the media that we're going to introduce our plant. Maybe let me do a little explanation. So before you do genetic transformation, you require tissue culture. And tissue culture is that you're getting your plant, cassava and yam, sweet potato from the field, and you provide an artificial environment. So this is an example of an artificial environment. This is a containment system. And inside the containment system, you have your media. So the media is providing what the soil provides. The soil provides macronutrients, micronutrients, and vitamins. So we make those provision in this media. And this is the room where we make this. Important equipment I want to show you here is, so we have the autoclave. Now, because this media is high in sucrose for the plants to use, and it has other nutrients that can encourage microbial growth. So it is important that after making your media, that you need to autoclave it. So this is an autoclave, whereby, as what she's doing is one of the things, she's preparing the media. After doing that, you put it in the autoclave. And another important equipment here is a distillating machine. So because we need distilled water, so we need to produce our distilled water from here. So also here you see she's preparing the media I talked about, and she's checking the pH, because it needs to have the correct pH. If you have the pH, normal pH for plant to grow is about 5.8. If you have higher and lower, the plant will not do well. So we need to take those measures from here.
RVA is a rapid viscoanalyzer where you used to check pasting properties. There are, most importantly, pasting properties, that when I mean it's properties that has to do with baking, cooking for flour. When you talk about the viscosity, the temperature at which it could bind, and at which you could use it for baking, this machine gives you an overview of it. It gives you both the temperature at which it can gel, the temperature at which it can break, and even the viscosity it can reach before it breaks, which is the trough viscosity. So this machine gives you everything, and it comes out also in a graphical representation. First, this is a texture analyzer. This is a TPA, and it's a new machine, and it's very, very, very important, and it's one machine we use to test the texture of food products. Most importantly, you talk about fufu, gari, and other products, even baked products. You test the quality of it, the texture. And I think far back, people use normal sensory to do that. You use your tongue to taste, you use your hand to feel, but now this machine does everything and gives you. We've been doing some tests, and we've run a concurrent using the consumers for the sensory and we've gotten a very good result. So in the near future, or probably from now, this is the machine we will use to check for texture analysis.
I hope you're following us and you enjoy how the program is rolling by. Let's take a quick break. Yes, don't go anywhere. Sit back, relax, and enjoy as we quickly go for our business and then return back to the studio. Stay tuned. It's still the program Agric Today, and we've been looking at the improved version of roots and crops and how it's being done. And today's focus is on cassava. And then we've been going around. We've spoken with the coordinator in charge of the institute in Abia State, Umudike to be precise. And of course, going to the last lap of, you know, how I wouldn't call it a roadshow, but you know, it's something like it because it's entertaining, and you know, and then we learned so much during this trip. And in the process of this last lap, we met Dr. Joseph Onyeka, the Director of Biotechnology Product Development, still under the institute, and you know, they gave us the different varieties of cassava they have in their lab, and what you know, the people prefer in the market. If you ask you and I, we just know that cassava is cassava, but you know, those in the business of this cassava and those, you know, using it as an end product, farmers, they know the different types of cassavas. So let's hear from them. Let's hear from the coordinator and you know, the director in charge of this lab. Stay tuned.
You're welcome to SAH lab. So SAH means semi-autotrophic hydroponic. So we're going to show you what we're doing with that technology. So this is another anteroom because of contamination, where you exchange your footwears. So this is our preparation room. So what is SAH? What we're doing normally is like you see this container. Okay, so what you have inside is a substrate. So hydroponic normally means that you're growing plants without soil. So you can grow it in water, you can grow it in soilless materials, which is something like this that is called a substrate. So what we're doing here is to grow our plants in this container, and we'll show you the magic while we're doing that. Okay, so in the preparation room, what do we do? So we have, this is where we mix our substrate, we sterilize it, and then we use solutions. So these are nutrient solutions that we prepare. We use the constituent chemicals for macro, micronutrients, and we produce solutions of those nutrients, and we mix them together in this substrate, and it's ready to go. Okay, so this is our cutting room where we cut the plants. Okay, right, so and I really want to appreciate, this is one of our technologists. She's really working very hard, and she's another person. They are the ones maintaining this laboratory. So like I told you, see what we're doing. So this is cassava that is planted in here. So the secret here is that this is for seed multiplication, and this technology is being supported by the BASIC project. So, and BASIC is all about producing cassava seeds. So what we're doing here, if I want to produce cassava seed in the field, I plant 2 nodal cuttings of cassava in the field. It takes me about 8 to 12 months for me to have a cassava stem of about maybe say 10 nodes, right? 10 nodes. So I'm only producing about 5 planting materials with one, right? But here, see what I do. This place can contain up to 15 or 20. In 4 weeks, they are grown like this. And then I'm able to cut it back. See what she's doing? This is called pruning. So she's able to cut them and put them in another container. So in another 4 weeks, I'm cutting again and putting in another container. So it's a geometric multiplication system for planting materials, for cassava planting materials. This is the beauty of this technology, right? And again, it needs constant light for us to get this. Okay?
So from down, it will grow.
It will grow. Yeah. So this is what she did to get this. Is that farmer preferred cultivars, the plants that are high demand. So we're multiplying them here. So you could see, you see this is Dixon, and this is Sunshine. This is, which other one? TME419, and this is Fine Face. So there are different cassavas.
Baba 70.
This is Baba 70. So Obasanjo. So these are materials that are in high demand. So we are multiplying, and then we take it to the field. And I would want to recognize he's my director, and he's the one that is also the PI for the BASIC project. So they are the ones that are supporting this project.
Yes.
Thank you. The hands that are on ground to do the work. You may make the resources available for the people on ground to do the work, and that's why she took time to recognize the technologies that has been doing the work. We appreciate this cooperation of everybody.
Yes.
And thank you for visiting us. Why do we have named that? I've seen Obasanjo too. Well, before now, there is a TMA one that they call Obasanjo. And then we have this improved variety, and then he said it's similar to it, so we call it Obasanjo too because it's popular, accepted there. But if you check the name, apart from the name of individual, there are names that makes that tell story. Like, look at something like Game Changer. Said we share these varieties in our development process with farmers, and they grow it in their field. And then when we went back to them and asked them questions, some of them say that this particular variety you're giving me is just a game changer. That when you pull one stand, you can have a whole basket load. And so they said, if you have this in your farm, you have stepped up your game. So we call it Game Changer. Then we have other names like Dixon, where Dr. Alfred Dixon of ITA is a Sierra Leonean, but has been in Nigeria for over 32 years working on cassava. In fact, he supervised many of us in our postgraduate studies, and he has been a key player in the release of so many varieties of cassava in Nigeria. In fact, he's a chieftaincy, a traditional title holder in Osun State by the Babagbe in Osun State. So we, in the process of developing the variety, he played a key role, and then the farmers feel that, oh, this man that we have been knowing, we should name one in honor of his name. So that's why we call this Dixon. So it's in honor of Dr. Alfred Dixon of ITA.
See fine face there.
And then we see fine face, of course. When they process into Gary, they like it because we are not only looking at the roots, but we say processing. So you process different varieties of cassava into different Gary product, and then ask them, say this one is fine. When you look at it, you like the face. So we call it fine face. And so that's how we came about the names. So you see it, we call it fine face. And then we have TME 419 is a popular land race, and we kept that name. Of course, so these are the names, how we came about these names. We make sure we carry the end users along. You have the one that when you harvest it, and you can use it to process fufu, you can pound it very well, and the farmer say this is poundable. Unlike the one that you can boil and pound, so it's called poundable, and you have a poundable, and it's another solid land race that have been in circulation among the farmers.
Yes, I hope this episode has been very edutaining, and when I mean edutaining, it's been educative and entertaining at the same time, because yes, I really do learn a lot from this episode. Don't forget to like our YouTube, and of course send us your messages if you have your reservations, you have your contributions, or you have something very interesting as regards the program that you want us to come and cover. Don't hesitate to reach out to the admin and the number on your screen. I remain your host, Amin Khadija Oluwatoyin. Next week promises to be another exciting one. Catch ya.